Lesson 18.2, Task 3. Solve equations by completing the square. You can solve equations of the form ax squared plus bx equals c by completing the square. When doing so, you must be careful to keep the resulting equation equivalent to the original equation. Solve 3x squared plus 2x equals 1 by completing the square. All right, there's two different methods we're going to look at, so let's look at method 1 to begin with. So the first thing they want to do is 3x squared plus 2x equals 1. We know that the first term has to be a perfect square, and 3 is not a perfect square. So step 1 is going to be to multiply the entire equation by 3. And if you remember, it says be careful that you keep the resulting equation equivalent to the resulting equation. So what that means is when we multiply this equation by 3, we have to do the same thing on both sides, and you have to multiply the whole equation. So they put this in parentheses so that both terms get multiplied by 3. So 3 times 3x squared is 9x squared. 3 times 2x is 6x, and 3 times 1 is 3. So this equation is 3 times larger than this one, but it's equivalent to that equation. All right, we just wrote it in a form where we can complete this square. All right, now to complete this square, remember there's a couple different ways you can do it. You can either draw the picture, or you can do b squared divided by 4a. All right, so whichever way you want to do it. So let's look at the algebra tiles first. So if we do algebra tiles, okay, so this is our 9x squared, and then we need 6 x's. So I'm going to pretend like those that don't look like rectangles. Let me make these a little bit smaller. All right, so these should be rectangles because these are our linear terms. And then I need one individual term. So that's going to complete the square. So I just need a 1 there. Okay, so you can see that if you draw the algebra tiles, the 9x squared and then the 6x's produces this 1x here. So you can do that to find the 1. And then you have to add 1 to both sides. So again, you have an equation. If you add something to one side, you have to add the same thing to the other side. So now we're going to factor this. We know we can factor this as a perfect square because we made it a perfect square by using the completing the square method. So we're going to have 3x plus 1 quantity squared. Remember, the middle term is built in. It's the 2ab. And then equals 3 plus 1 is 4. Once this is in factored form, now you can solve this equation by simply taking the square root of both sides. So take the square root of both sides. The square root is going to cancel the square term on the left, and then you're going to have plus or minus the square root of 4 on the other side. So then I'm going to have 3x plus 1 equals this, and I'm going to subtract 1 from both sides. All right, when you subtract 1 from a plus or minus 2, you have to subtract 1, you have to do negative 1 plus 2. Negative 1 plus 2 is 1, and then negative 1 minus 2 is negative 3. So in this next step here, the 3x equals 1 comes from negative 1 plus 2, and the 3x equals negative 3 is the 3x equals negative 1 minus 2 here. Then divide both sides by 3, and you get your two solutions, x equals 1/3 or x equals negative 1. So this is method 1 for completing the square. So it says the equation 3x squared plus 2x equals 1 has the form ax squared plus bx equals c. Choose phrases to complete this statement. Both sides of ax squared plus bx equals c were multiplied by a. Remember, it was a was 3, and we multiplied by 3 to make it a perfect square. So 3 times 3 is 9. So we multiplied by a to obtain a perfect square. All right, which statement explains why 1 is added to both sides of 9x squared plus 6x equals 3? Select all that apply. So to complete the square, you have to add b squared over 4a. Remember, so that's, I drew the picture here, but you could also do this as well. So you could also do b squared over 4a. And if you check that, you know, b squared over 4a, b squared would be 4, and 4 times a is 12. Oh, wait a minute. Wrong equation here. This is the equation where we're completing the square. So I'd have to do b squared. 6 squared would be 36. 36 over 4 times 9 is 36. 36 over 36 is 1. And 1 is the number that we added to both sides. All right, the right side of the equation needs to be a perfect square. We're usually working with the left side, so we're not going to worry about the right side being a perfect square. So we're not going to choose that one. Adding 1 to both sides forms a perfect square trinomial. So in this case, adding 1 to both sides did make this a perfect square trinomial. Okay, so we're talking about just this example here. All right, at one point in the solution, you have the equation 3x plus 1 quantity squared equals 4. Complete the statements. One equation says that the square of 3x plus 1 is equal to 4. The definition of a square root tells you that if a square of an expression equals k, then the expression equals plus or minus the square root of k. All right, that's your definition of square root. Remember, we've got to have the plus or minus square root there. Therefore, 3x plus 1 equals plus or minus 2, because the square root of 4 is plus or minus 2. All right, which statements explains why there are 2 possible answers? Select all that apply. All right, every quadratic equation has 2 answers. No, it has 2, 1, or 0 answers if there's no solution, so that's not true. Every number has 2 square roots. That's not true either, because 0 only has 1 square root. The graph of y equals 1 intersects the graph of y equals 3x squared plus 2x at 2 points. All right, so what they're saying is if you take this quadratic equation and graph it, it'll intersect at 2 points, and that is true. And the 2 points where it would intersect would be 1/3 and -1. All right. And then it says the equation u squared equals 4 has 2 solutions. So in this case, we were using u equals 4, and that was the plus or minus the square root of 4. So yes, in this case, it has 2 solutions. All right, now let's look at the second method for solving using completing the square. So 3x squared plus 2x equals 1 is the same equation from method 1. This time, instead of multiplying the whole thing by 3, we're going to divide the whole thing by 3 or multiply by 1/3, which is the same as dividing by 3, to get a coefficient of 1 in front of my x squared. All right, so now the thing that happens when you do this, you still have to divide everything by 3. So 3 divided by 3 is 1. 2 divided by 3 is 2/3. And 1/3 times 1, or 1 divided by 3, is 1/3. So what happens here is it still works, but now you're going to have fractions to work with, which isn't so bad. All right, so x squared plus 2/3 x equal, or plus 1/3 squared. All right, so what they did was complete the square. So I'm going to take this middle number, half it, and square it. So let's see where they got that number. So 2/3. Remember, we're going to take it, we're going to half it, and then we're going to square the whole thing. All right, don't know why my parentheses went wild there. And let me start over. All right, so I've got 2/3. I'm going to half that, and then I'm going to square it. Still made a funny parentheses there, but All right, so the first thing I'm going to do is work inside my parentheses. So I'm going to do half of 2/3. So 2/3 times a half is the same thing as multiplying by the reciprocal. So it'd be 1/2, which becomes 1/3. And then if I take 1/3 and square it, 1/3 squared is 1/9. 1 squared is 1, 3 squared is 9. Okay, so what we're doing is rewriting this here. They just left it as a perfect square because we're going to write it in factored form in the next step. So we have 1/3 already here. If we add 1/3 squared to the left side of the equation, we have to add 1/3 squared to the right side of the equation. So now I can take the left side and put it in factored form. I made this a perfect square trinomial, so now I can write it as a binomial squared. So remember, x squared is just x. 1/3 squared would just be 1/3. So x plus 1/3 quantity squared is the factored form of this. Then we've got 1/3 plus 1/3 squared. Remember, 1/3 squared is actually 1/9. And to add 1/3 and 1/9, you have to have a common denominator. So 1/3 plus the second one is 1/9. Remember, I have to get a common denominator, which would be 9. So 3/9 plus 1/9. That's how they get the 4/9. So the 4/9 comes just from adding two fractions. All right, now the next step, take the square root of both sides, and look at that. It's very nice. Both of these are perfect squares, so that makes it easier. All right, so take the square root, cancels the squared term on the left. I'm going to get plus or minus, and the square root of 4 is 2, and the square root of 9 is 3. So I'm going to get plus or minus 2/3. And then I'm going to do x plus 1/3 equals 2/3. And then x plus 1/3 equals negative 2/3. And when I add, or I subtract 1/3 from both of those, I still get the same answer as I did above. So this is just a different method. You can choose either method you want. Remember, the first method was multiply the whole equation by 3. And the second method was divide the whole equation by 3. So what we're doing is just finding an equivalent expression. Okay? All right, so Method 2 proceeded by obtaining an equation whose x squared minus term has a coefficient of 1. Complete the statements explaining how this was done. Both sides were multiplied by 1/3. This worked because the multiplier was the reciprocal of the coefficient of x squared. Which statement explains how you find the value 1/3 squared, which was applied to both sides of x squared plus 2/3 x equals 1/3. Select all that apply. So the expression represents b squared over b at 4a. So that is true. And then this equals this. So I did show you how that worked, but let's look at it again real quick. So we've got 2/3 squared over 4. 2/3 squared would be 4/9 divided by 4/1 because this is just a fraction. So I'm going to have 4/9 times the reciprocal of this, which is 1/4. So that equals 1/9. And 1/3 squared is 1/9 as well. So what they're doing is just working with fractions there. All right, so it says check by substitution. So 3x squared plus 2x equals 1 is your original equation. You're going to plug in your two answers. So you're going to plug in 1/3 and see that it works, and then you're going to plug in -1 and see that that works as well. All right, that's all for task 3. If you have any questions, let me know.